Alright, in this video we're going to look at the parabola. So the definition of a parabola is a locus of a point which moves in a plane such that its distance from a fixed line on the plane and its distance from a fixed point on the plane but not on this line. So the two distances must be equal. Then you have a parabola. So let's just demonstrate this. If you have, say, this fixed line here, and you have this fixed point here, then for starters, so just notice that the distance from the line is talking about the perpendicular distance, okay, or the shortest distance from the line. So for starters, the midpoint of this line is going to be where we start, so that this distance is equal, so that this distance is equal to that distance. And then this point is going to move such that the distance from this point is equal to the distance from that line. So basically you're going to have this type of movement. Maybe just so that if you go to this point, for instance, that is the same distance as if you go to the line there. Okay, so this is the situation we're going to have now. So at all points here, this distance must be equal to that distance there. Okay, then you have a parabola. Now the fixed line is called a directrix, or the directrix of the parabola. The fixed point is called the focus of the parabola. Now you're going to notice that this thing is going to be symmetric. So the line of symmetry is called the axis of symmetry, or just the axis of the parabola. And this point, which is midway between the line and the point through the axis, is called the vertex of the parabola. We've got the vertex here. Now let's talk about the equation. I'm just going to do a quick derivation of the equation of this parabola here. So take the instance or the case where the vertex of the parabola goes through the origin. Okay, the distance from the vertex to the focus, or the fixed point, is called P by definition. So that distance is going to be the same distance as the distance from the vertex to the fixed line here, which is the directrix. So that means this is going to be P here, and that is going to be P as well. So that means the equation of this line is going to be y equal to negative P. of course the coordinates of the focus will be 0, p. Now if we take a random point on the parabola, actually it looks like my sketch here should be something a bit more like that, although of course this is a sketch, it's not to scale, but I'm just trying to make sure that these distances will at least look like equal. So this distance must always be equal to that distance there. All right, now so let's take this to be any point xy on the parabola. Okay, then since this is a vertical line, so if this is xy, it means distance from here to here is x, and the distance from there to there is y. We just said this distance is p, which means the vertical line distance there is simply going to be y plus p. Then the distance from 0p to y to xy is going to be the square root of, we're going to have x minus 0 squared, which is x squared, then we're going to have y minus p squared. Okay, then if we square on both sides here, so this side is just going to be x squared y minus p squared, so this is going to be y squared plus 2yp plus p squared. On this side we've got x squared plus y squared minus 2yp plus p squared, and then well, p squared is going to cancel out, y squared is going to cancel out. Then if we take the two yp terms to this side, so the equation we're going to have is 4yp is equal to x squared, and so this is actually the equation of a parabola whose vertex is at the origin, which opens upwards. Now notice here p can be positive or p can be negative. If p is positive, the parabola opens upwards. Okay, so if p is positive, the parabola opens upwards. If p is negative, then the parabola opens downwards. So p is negative, then the parabola is going to look something like this. Now we're going to take the case where the parabola has got vertex at a point different from the origin. So if the parabola is has got the vertex at hk, okay, so suppose parabola is somewhat like this, the vertex is at hk, everything else is still similar, then all we're going to do is the y here is going to be replaced by y minus k, which is this coordinate here, and the x is going to be replaced by x minus h. So that means for this case here, the equation is simply going to be 4p y minus k is equal to x minus h all squared. the vertex is at HK and the axis is vertical. Then the other case we're going to look at is the case where the parabola has got a horizontal axis. So in this case, the parabola could open to the right, or it could open to the left. Okay, going to open to the right if P is positive. It's going to open to the left if P is negative. So P is positive here. Otherwise, the equation is going to be this one, but X and Y are going to change roles. So the equation for this one is now going to be 4P, it was 4PY is now going to be 4PX is equal to Y squared. And then again, if the vertex is different from at a location different from the origin, then we're simply going to do the transformation on those equations. So it could open to the left if P is positive. It could open, sorry, this is to the right. It could open to the left. Our vertex is now at HK. So the equation is now going to be 4px minus h into y minus k all squared. By the way, this equation is the standard form as we head for the circle. Then the general form for this one, for instance, you make x the subject of the formula. So it's going to be xay squared plus by plus c. So this one is the general form. For the case where the axis is vertical, so here if we make y the subject of the formula, then your general form of that equation is going to be y equal to ax squared plus bx plus c. This is like your standard equation for quadratics that I'm sure you will be familiar with. All right, so that's all in terms of the theory. Let's look at some examples now. Okay, before we look at the examples, we're just going to note that so here this is the standard form, this is the general form. Again, to go from the general form to the standard form, we complete the square, and to go from the standard form to the general form, we simply expand the brackets, right? And then the other thing, if it's the x that is squared, then the axis of the parabola is vertical. So it means it either opens upwards or downwards depending on the sign of P. If it's the y squared that is squared, if it's the y that is squared, then the axis of the parabola is horizontal. It either opens to the left or to the right. So in these examples, we are given the equation we will want to find the coordinates of the vertex and the focus, equation of the axis and the directrix, and then we are going to make a sketch. In A, it's the y that is squared, so that means the axis is going to be horizontal. Got y squared is equals to 16x. The thing we're going to do is we're going to want to write it in this standard form. Okay, well, it's the y that is squared, so it's going to be the standard form. So y squared is equals to 4px. So in this case, if we write 4, it means p is 4. So this is telling us that p is 4 and p is positive. We've already established that the vertex is going to be at the origin because it's this form here. Okay, so the vertex is at the origin, p is positive, which means the focus is going to be here for 0. And since p is positive, it means this parabola is opening to the right. Now you're going to notice that these type of questions, it's going to be useful to do your calculations as you go as you do the sketch. Don't try to find focus and the vertex and everything first before you do the sketch. It makes sense to piece them together step by step. So we already have the coordinates of the vertex, so that's going to be 0, 0 there. There is the focus, there is the directrix, which means the equation of the axis is y equal to 0, and the sketch is already here. So question A is done. Then I'm going to go to question B. We've got x squared is negative 9y. Okay, so this time is the x that is squared, which means the axis is going to be vertical. Next thing, we need to decide the value of p. So we're going to write this as 4 times something. Okay, now that something is going to be minus 9 over 4 y. So this is our p. So this is telling us that p is negative 9 over 4. Now since p is negative, it means this parabola is opening downwards. The vertex is at the origin, and so the focus is going to be at 0 minus 9 over 4. Directrix is going to be same distance as the focus from the vertex, so it's going to be at y equals 9 over 4. And so the axis is going to be x equal to 0. All right, and then for C, the equation is x squared minus 2x minus 12y plus 25 is supposed to be equal to 0. Okay, so we've got x squared minus 2x minus 12y. Is it plus or minus 25? Plus 25 is equal to 0. So here the idea is to first separate the x and the y variables. You can see that in each of these forms the x's are on one side and the y's are on the other side. Okay, and then complete the square on the side with a squared term. So we're going to write this as x squared minus 2x is equals to 12y minus 25. And then we're going to start by completing the square on the left hand side. So if we do that, this is going to be x minus 1 squared. Then that means the right hand side we're going to have to add 1. So that means the right hand side is now 12y minus 24. Then what remains is for us to write this right hand side as 4p something. So if we factor out 4 here, okay, so first of all, maybe let's just factorize 12. So this is 12 into y minus 2. Okay, and then this we can write as 4 times 3 y minus 2. Okay, so this becomes our p. So p is equal to 3. The vertex is going to be 1, 2, because notice, so the vertex is hk, then we've got minus h here and minus k here. And since it's the x that is squared, this the axis of this parabola is vertical. So we're going to, if this is 1, 2, okay, p is positive, so this thing is opening upwards. Okay, and then a distance of p up from 1, 2, we are going to have our focus. So the p is 3, so 1, 2, and then plus 3, that's going to be 1, 5. So that's going to be the focus. And then if we take away 3, then here y equal to negative 1, that is going to be the directrix. Of course, the axis is x is equal to 1. All right, so that sorts out that one. Let's go to the last one, which is D. So in D, we have y squared plus 4y plus 20x plus 4 equal to 0. So we're going to do the same thing. So y squared plus 4y, this side minus 20x minus 4, this side. Then we're going to complete the square here. So y plus 2 all squared minus 20x minus 4 plus 4. So that's just going to be minus 20x. So this we can write as negative 4, sorry, not negative 4, 4 times negative 5. And then here we've got x minus 0, which means that p is negative 5. Vertex is going to be at 0, negative 2. Since y is squared, this parabola is going to have a horizontal axis. So let's do the sketch. So the vertex is going to be at 0, negative 2. the axis is horizontal. P is negative, so that means this thing is opening to the left. So that means the focus is going to be somewhere here, dictated by the value of P. So that means the focus is going to be at -5, -2. And then this side, x equal to 5, is going to be the directrix. And of course the axis is y is equal to -2. Okay, so that is that one. Let's just give you one to have a go at. Alright, so please have a go at this one. You can pause the video, work through it, and then when you press continue play, then you can compare with our answer. Alright, we're now going to go through this example E. So if we bring the terms to different sides, the y terms on the left hand side and the x terms this side, complete the square, then this is going to give us 4 into x minus 2. So if you write it in the form 4p times x minus something, then p is 1 here, and of course then the coordinates of the vertex will be 2, -3. 2, -3 is in the 4th quadrant. Since it's the y that is squared, then the axis of this curve is horizontal. The focus is going to be a distance of 1 from the vertex horizontally, and the directrix will be this side. Okay,